Hello, everyone. Imagine this. You wake up one morning, grab your phone, and say, "Hey Siri, what's the weather today?" Your phone responds with the forecast. On your commute, you dictate a text message to your colleague. At work, your team analyzes customer feedback to understand satisfaction levels. What connects all of these experiences? They're powered by specialized NLP technology. Not the headline grabbing large language models we hear about daily, but focused tools that excel at specific tasks, converting speech to text to speech, and analyzing sentiment. Today, my colleague Hamzeh Shuqair and I will take you behind the scenes of these technologies to compare commercial solutions like Google Cloud with open source alternatives. We built a web application that lets us see these systems in action side by side to understand when it makes sense to pay for premium services and when free alternatives might serve us just as well. Before we dive into the comparison, let's clarify what these technologies do and why they matter. First, text to speech or TTS gives AI a voice, transforming written content into natural sounding speech. This powers everything from audiobooks to accessibility tools for visually impaired users. Second, speech to text or STT makes machines listen, converting words into written text. This enables voice commands, transcription services, and voice assistants. Third, sentiment analysis. It teaches computers to feel or at least detect human emotion in text. And this helps businesses understand customer opinions, monitor brand perception, and improve experiences. Together, these technologies enhance human computer interaction, making digital experiences more natural, accessible, and responsive. Now, it's time to meet our contenders. In one corner, we have Google Cloud API, the tech giant's comprehensive offering, and it comes with trained models, wide language support, and enterprise level reliability. In the opposite corner, we have our open source alternatives. First, SpaCyTextBlob for sentiment analysis. This is a Python powerhouse. It's free, but requires some setup. OpenAI Whisper for speech to text. This is the new kid on the block, making waves with its accuracy. And third, it's the Microsoft Edge TTS, and it offers, surprisingly, natural sounding voices. Each has different strengths and weaknesses and ideal use cases, and all of them we'll explore throughout this presentation.
Thank you, Ariel. Now we're gonna move on to the bread and butter of today's presentation for the project. And we're gonna discuss first Google Cloud API, the all-in-one solution. We're gonna talk about the pros, cons, and everything in between. Now, Google Cloud offers a comprehensive suite of natural language processing services with advantages and some drawbacks, of course. First of all, we found out that it's pretty scalable and supports multiple languages. It offers high quality and well documented APIs, and it also provides consistent performance across all three functions. However, the processing can become complex as you scale your project. For example, in our use cases, we faced some pretty minor charges. For example, 16 of a thousand of a dollar per 15 seconds of text to speech, which is less than 2 cents per 15 seconds. You can say time that by 4 to get a minute, and that's like how much? Six cents, something like that. And for the speech to text, it was almost half a cent per 15 seconds. This also is heavily reliant on how many API calls you make, which can scale up pretty well if you're offering this to users and customers. And there's also the potential vendor lock-in as you build your systems around their APIs. So if at some point you decided that it's a financial burden to continue with Google Cloud, and you decide to move on to a cheaper or even free source, as you guys can see. If you're gonna move on to a free source services, it can be a bit harder to shift all these services that you're using. So we're gonna be starting off with our first contestant, which is SpaCyTextBlob. SpaCyTextBlob is a sentiment analysis specialist. It offered an impressive alternative for Google Cloud during our testing. It was lightning fast, it analyzed text almost instantly, provided reliable sentiment across the board for the English language, and it was very good. And the most important part out of this is that it's completely free and open source. However, you will need, if anyone is implementing this, they're gonna need Python knowledge to implement it. But for teams with the technical capabilities, it offers substantial cost savings comparable to accuracy to Google's sentiment analysis. Next up on the list is OpenAI's Whisper, the revolutionary speech-to-text. Whisper represents a breakthrough in open source speech recognition. It supports dozens of languages with impressive accuracy. It can handle accents, background noise, and technical vocabulary, which we found pretty interesting to see punctuation in the output from the testing. And by comparing that to Google API was kind of lacking in that field. So it was kind of refreshing to see a free source being this accurate in its transcription. And it's also, of course, free for self-hosting. The trade-off, though, it's computationally intensive and requires significant resources to run efficiently. This is because they use autoencoder and decoder neural networks to perform the transcriptions. However, for organizations with the technical infrastructure and capable resources, they can use it, and it matches or even exceeds Google's accuracy in many scenarios. Last but not least, we have Microsoft joining the competition again with its Edge text-to-speech. Speaking from the edge, Microsoft Edge text-to-speech surprised us with its quality. It offered remarkably low latency, and it could also work offline, eliminating the need for internet connectivity. For some people out there, this could be a game changer, since you don't have to be connected to the internet at all, unlike Google Cloud. And its voices sounded natural and expressive. It's almost like they have some sort of emotional built into it to give it the natural-esque type feel, which some people might appreciate. Me personally, I prefer that over the regular robotic voice. For applications where consistent voice quality and offline capability matter, Edge text-to-speech provides a compelling alternative to Google's offering. Now, for the final battle, the moment that everyone's been waiting for, the battle of the tools, we have a head-to-head comparison between all four services and how they fare against each other. We're starting off with Google Cloud, which supports all three functionalities, but at a cost which we have discussed. We have SpaCyTextBlob that excels at sentiment analysis, but only sentiment analysis. We have Whisper, which handles speech-to-text brilliantly. We have Edge text-to-speech that delivers quality text-to-speech and quite the performance at it. Now, as far as the data goes, we can see it in this head-to-head comparison, how they fare against each other. We came up with a metric as the ease of use metric, which is a rating that we give to each service, and it revealed an interesting pattern here. Google and Edge text-to-speech are the most developer-friendly to implement, while Whisper and SpaCyTextBlob they could require more technical expertise to implement. Now, as far as how we determine accuracy and speed, and what metrics we use to measure the performance. Accuracy is paramount when it comes to speech recognition. In professional settings, precise transcription is a prerequisite for building great customer-facing apps, of course. The same thing goes for speed. While not all use cases require an instant output from the API, Given the recent advances in speech recognition text, it is expected that transcription shouldn't take longer than a few minutes for an hour long video. Now, as far as the metric used for performance measurement, we have the most common metric used to assess transcription quality in this industry is the word error rate. Word error rate takes into account the number of words substitutions plus the number of word deletions plus the number of word insertions. All of these are added up together and divided by the number of words in the reference text. Now, for our use case, we used OpenAI's Whisper version 1. While we couldn't calculate an accurate measurement of the word error rate, Whisper took an average of 1 second of processing per 1 second of audio, and this of course does not scale well despite its accuracy and good punctuation detection. However, we came across a blog post done by Gladia. They performed some testing on Google, speech to text, Whisper, and Amazon to determine which one is the better service. And since we're interested in Google speech to text and Whispers, I have included these little results that Gladia conclude. OpenAI's Whisper version 2, it was the most accurate out of all these services. It had a median error rate of 8.06%, and it took on average 10 to 30 minutes to transcribe 1 hour of audio. Now, moving on to Google speech to text, it appeared less accurate with their testing, with a reported error rate ranging from 16.5% to 20.63%, and an average speed of 20 to 30 minutes for an hour of transcription. Now, this could be a big deal for some of the people out there, since 8% is pretty good, given that the audio is like 1 hour or at least 1 hour, and could take 10 to 30 minutes depending on the complexity of the words being there and the clarity of the audio file itself, of course. But having an error rate of almost half than the best that Google Speech to Text can do is by itself pretty impressive. This goes to show us that for Google Cloud, one could say that the limit is the sky, but actually there is no size fit all. There is no free lunch. While Google Cloud can offer all these functions from a single service, it can still fall behind a free open source service. We built a humble and simple website which we use to call these APIs. We live tested them in real time. We visualized the results to help us determine which one is the better solution and see the scores, the confidence, the magnitude of each solution, and how they determine and extrapolate the information to reach out to the conclusion. For example, was very useful in sentiment analysis. And this website is highly scalable. We can edit and add any function that we would like to test in the future, which can help in scalability issues and concerns, adding other functions that might be interesting to some. And my colleague Ariel is gonna show us a demo of this website. Back to you, Ariel.
Now that we covered the theory behind all of this NLP technologies, we wanted to also showcase a platform we've built. This website enables us to compare both the Google Cloud's API solutions and the open source tools we've used. So, as you access the website, you can select either to test each of the functionalities by themselves. Here, if you select the speech to text conversion, you can select the Google Cloud solution or the open source. In this case, it is the Whisper solution. from OpenAI. You select the text to speech, it's the same case. Here we're using the Edge TTS. And as you select the tool, it also changes the voices that come with it. So if we select the open source, we can see another list of voices. A more interesting tab, and the one that we'll use for this demo, is the comparison tab. This enables us to see both of the results side by side. So let's test first the sentiment analysis, and let's use a positive review from one of the Avenger movies. So here's the review. This film is an emotional roller coaster with some of the coolest superhero plot lines ever drawn up. This is obviously a positive review. Let's see the result for both of the solutions. So as we can see, here's the Google Clouds and open source results. And both of them are positive, but with different scores and magnitudes. It is important to know that with open source tools, you're able to switch and tweak certain aspects and certain parameters so you can get better scores or tweak it for specific use cases. So let's test the text to speech. We can use the same review, and let's select a female voice here just to have the same type of voice in both cases. Let's run the comparison. So let's hear it out.
This film is an emotional roller coaster with some of the coolest superhero plot lines ever drawn up.
Now let's hear the open source result.
This film is an emotional roller coaster with some of the coolest superhero plot lines ever drawn up.
In terms of sounding natural, it is a comparable result. So we can also test the speech to text. And if you back out and you refresh here in the dashboard, you can see the results gotten so far. So let's test the final functionality for this tool. So let's record a message, let's say a negative message, just to have that be analyzed for the sentiment analysis. I hate the Avengers movies. I think they are boring. It is important to know that this is a fictitious example. So let's run it up. I hate the Avengers movies. I think they are boring. So now we can see that it was recorded successfully. Let's run the comparison. It's important to know this takes this much time because of one of the tools. The Google Cloud, it doesn't take much time to run. But the Whisper tool, as it is an encoder-decoder neural network, it takes more time. It's more computationally taxing. So we can see here the transcription. I hate the Avengers movies. I think they're boring. This is the confidence. And we integrated to all of the speech to text and text to speech functionalities a sentiment analysis just to have both of them be tested at the same time. So we can see that both of them select the negative sentiment or classify this text as negative. So if you want to test out all of these tools, or maybe even give it a try with this website, we'll publish a repository down in the description of this video for you to download, check out the actual code, the implementation, and test it out for yourselves. As we wrap up, here are the key insights from our comparison. First, there's no one-size-fits-all approach. The best solution depends on your specific needs, budget, and technical capabilities. Second, consider 3 key factors when choosing: accuracy requirements, processing speeds, and cost constraints. Third, open source solutions offer free alternatives, but often require more setup and technical expertise. And fourth, this is a rapidly evolving field with new innovations emerging constantly, for which we should stay up to date with, as there can be even better offerings both in the paid and open source realms. So, The NLP landscape has transformed dramatically in the recent years. While LLMs get the headlines, these specialized tools handle critical day to day interactions between human and machines. For startups and cost conscious organizations, open source alternatives can now deliver performance that rivals commercial APIs in many use cases. For enterprises needing guaranteed uptime, extensive language support, and minimal development overhead, Google's solution remains compelling. The real power comes from understanding when to use each approach. With the comparison website we've built, you can experiment with these technologies yourself and make informed decisions for your specific use cases. Thank you for your attention. Please feel free to ask any questions or add valuable comments down in the comment section below.